Find the exact value of all 6 trigonometric functions evaluated at the indicated angle theta. All right, so I've been given 2 sides of this right triangle. I'm supposed to evaluate the 6 trig functions at the angle. So I'm just gonna think about which ratio of sides each trig function is. And I guess first I'll be finding the value of the length of that missing side. So we can start with the Pythagorean theorem. 11 squared is equal to 3 squared plus the unknown side squared. 121 is equal to 9 plus the length of the unknown side squared. So let's say we need to take 9 away from both sides. That would leave me 112 is the square of the unknown side. So question mark would be the square root of 112. And since we want to be exact, we'll use that square root of 112, but we should always make sure that we should actually reduce under that radical if we can. So I look at 112, and I happen to know that 112 is divisible by 16. And when you're making a video, it's always, it's always nice to look like you knew that from the beginning. But truthfully, I thought to myself, well, that looks like it's divisible by 4. Well, 28 is also divisible by 4, so I knew there's actually a 16 in there. So I can rewrite that as 4 times the square root of 7. Now I'm ready just to think about my trig functions. Sine of the angle theta is the opposite side over the hypotenuse, so 4 root 7 over 11. Cosine is the adjacent side over the hypotenuse, so 3/11. Tangent, the opposite over the adjacent. And now I can just take reciprocals to find the other 3. Cotangent is the reciprocal of tangent. And if you wanted to rationalize that, we could multiply top and bottom by 4 root 7, just by root 7. On the top I get 3 root 7, on the bottom I would get 4 times 7 is 28. Secant theta 11 over 3, and then finally cosecant 11 over 4 root 7. And rationalizing, I would end up with that 28 on the bottom again and 11 root 7 on top. And there are the exact values of all 6 trigonometric functions evaluated at that angle theta.